A dietitian wishes to blend two foods, Nutrimax and Grammos, so that the mixture has at least 20 units of vitamin J, 14 units of vitamin K, and 40 units of vitamin L. The vitamin content of Nutrimax and Grammos in units per kilogram is shown in the following table. If Nutrimax costs $1 per kilogram and Grammos costs $2 per kilogram, find the minimum cost of the blended food. So the constraints here are the actual vitamins. If we let N be the weight of Nutrimax and let G be the weight of Grammos, then if we look at vitamin J first, 4 N's plus 2 G's has got to be more than or equal to 20. So we know that every kilogram of N has 4 units of vitamin J, so that's the 4N. Every kilogram of Grammos has 2 units of vitamin J, that's the 2G. So if we add those together, it's got to be more than or equal to 20 because we need at least. If we do the same for the vitamin K, then we need to have 2N plus 2G is more than or equal to 14. And do the same for L, and that's 4N plus 10G is greater than or equal to 40. And we can actually simplify these for plotting. So this one here would be 2N plus G is greater than or equal to 10. N plus G is greater than or equal to 7. And 2N plus 5G is greater than or equal to 20. Now we can put on the boundary lines and define the region. So the boundary line would be 2N plus G equals 10. So if G were equal to 0, N would be equal to 5. So that's just here. If N were equal to 0, G would be 10. That's up here. So that gives us this line just here, which is 2N plus G equals 10. N plus G is 7, gives us an intercept here of 7 and an intercept here of 7. So that's going to be this line across here. So that's N plus G is 7. And finally, for this one, if G is 0, N would be 10. And if N was 0, G would be 4. So that gives us this line just here. So that's 2N plus 5G equals 20. And for each case it was a greater than or equal to. So we need to be above all of the lines, and therefore the feasible region is this open-ended region up here. But clearly here we would also have non-negativity, so we would have those, and of course those would become important if we went beyond here. So this up here would be on the shaded region this side of the axis, and the same sort of thing down here. So we need the vertices of the region. Once again, if they're difficult to read, I don't think they are particularly on this graph, but if they are, you can use your calculator to help you find those vertices by solving simultaneous equations. So here we have 0, 10, 3, 4, 5, 2, and 10, 0. Now we can see the cost function is going to be n plus 2g. Every kilogram of this costs $2, every kilogram of that $1. So that's n plus 2g. And we want to evaluate that at each vertex. So that's 0, 10, 3, 4, 5, 2, and 10, 0. So that's $20, $11, $9, and $10. And so the minimum is just here. So our minimum cost is $9. And for that we use 5 kilograms of Nutrimax and 2 kilograms of the Grammos.